Here we go. Okay, so we are going to start a new section today. If you recall, I actually did not put this section on the test. We said 3.6 out of the book. We were supposed to do it right before the test, and I decided not to. Right? So that's what we're going to cover today. 3.6. It's called Introduction to Functions. It's on page 235. Introduction to Functions. Now, we are not going to do like a full-blown treatment of this section. We're going to pull the things we need out of this section, have a couple of homework problems on it, and we're going to proceed on. So if you try and read through the whole book or the whole section yourself, you'll notice that I'm skipping over some stuff. So 3.6, Intro to Functions. So the idea of a function is critical as you move forward in math. This concept of what is a function, and we use them all throughout college algebra. We talk about functions, things like cost functions, revenue functions, functions that describe things that happen in the real world. Okay, so before we can begin doing anything with functions, we need to kind of understand what they are, how they work. So I like to equate a function to a machine. So let's say you have one of my favorite, like a car wash, right? What do you put into a car wash? Dirty car, right? Hopefully, dirty car. I mean, you can put a clean one through. But the idea is you put a dirty car in, right? And what comes out of it is a clean car, if it's a decent car wash. I mean, and that's basically the idea of a function. We put something in, and something comes out the other side. But for us, for a function, we don't put in cars, we put in numbers, and functions spit out numbers. So I'll draw a picture underneath this same idea. Function for us, our in is going to be a number. And what comes out is a number, okay? But usually what comes out is a number we put in comes out changed. Now there is a function, a very special one called the identity, which actually you start with a number, and then when it comes out, it's unchanged. It's identical to what it started at. But that's a very special function. It's kind of irrelevant for us right now. We want to realize that functions are going to be things that changes a number to a new number, just like you change a dirty car to a clean car. Now, when you have this idea of a function, there's some important things that we need to note that don't happen. I mean, a lot of people look at these pictures as like, hello, you know, we're adults. You don't have to treat me like a kid, car wash, you know. But there's some things here that are subtle and they're important. So what about this? What if I draw, see my car wash? What if I draw an arrow coming out like this, and I put clean car, number 2. So look at what that is saying. I put one dirty car in, and what comes out the other side? 2 clean cars. Now, that would be, you know, a great business model right there, right, if you could make that happen. But that's not going to work, right? And functions don't work that way either. Functions, when you plug in a single number, it needs to spit out a single number. It can't take a number in and spit out 2 numbers. If it does, then it breaks down. It's no longer called a function. All right, it's just called a relation, and we're not going to talk about that. Okay, so I'm going to put something underneath here, underneath the number, and over here, I'm going to write 1 in, 1 input. I'll call it an input. That means one thing going in, 1 output. That's what you have to have a function. You have one thing going in, one thing going out. So that clean card number 2 is no good. Okay, so that's another condition of a function. 1 input, 1 output. Now, there's also some other things that we have to consider. With the car wash, if you drive up to the local car wash, you know the ones that are like at HEB, they have the one little car wash right next to the gas pumps, you know? You've seen them? Have you ever seen an 18-wheeler go through one of those? No, because it's not designed to accommodate an 18-wheeler, right? So there's with the car wash, it's supposed to take dirty car in, put a clean car out, but there are certain cars, types of vehicles you cannot put into a car wash, right? And with functions, sometimes there are certain numbers we cannot put into the function because the function will break, basically, right? You try and drive an 18-wheeler through the car wash, you're going to tear the whole thing apart. Well, our function can only handle certain things. So what we have here is, if you look at the car wash, it's kind of like, what can the car wash handle? Well, it can handle, like, subcompact cars. It can handle, the mid-sized sedans. It can handle full-size trucks. But then there's a certain point at which it can't handle, right? All the cars it can handle is called its domain. And that's what's happening with our function. All the numbers that our function can handle is called its domain. So I'm going to write under here, domain is the numbers we can plug in. Okay, so that's basically the domain is just saying, hey, what can that function handle? What can't it handle? And then out here on the right side, where the clean cars came out, all the clean cars that could possibly come out is called our range. We won't spend a lot of time on it, but I'm just gonna write it down for us. The range is all numbers coming out. And sometimes this range can be a lot of things, or sometimes it can be a few things. It just depends on the function. So the function will dictate a lot of this. We won't be able to talk about domain until I give you an example of a function. All right, so y'all ready? Y'all have a basic idea here? Okay, one number in, one number out. We have to be concerned about what we can and cannot plug in. So here's your first example of a function. Let's start with this. All right, now I'm going to write it like that, and then I'm going to explain what everything means, all right, because we have a lot of weird symbols in here. The F you see in front here is the name of the function. So what's the name of this function? F, okay? F, that's the name of this function. And the book likes to use F because F function, right? But you could have any letter you want there. G, C for cost, R for revenue. It's always the letter in front of that set of parentheses. Okay, now I will point out also, I could name a function if I wanted to. This will never happen in this class. But I could write a function like that, and the name of that function would be Robert. Okay, so it can be anything. Like in a business class, if anyone goes on to take like 1324, 1325 business math, you have cost functions, revenue functions, and sometimes they'll put the actual full name of what it is in front. Okay, but that's the name right there. Now, the set of parentheses around the X, that identifies the input. And right now, what we're saying is that in this function F, we are going to put in an X, okay? And then on the right side of the equal sign, 4x squared plus 1, that whole thing is the output. That's what the function spits out. So it's kind of like that's the machine. The machine is the 4x squared plus 1. It changes the X that we plug in. Now, if I were to be sitting here trying to read this to you, like if I were trying to say that line across the top, here's the way I would say it. Like in English, I would say F of X equals 4x squared plus 1. That's the way I would say that. The important thing there is, how do you say that first part? F of x. F of x. That's the way we say it. F of x equals the 4x squared plus 1. So now let's see how this machine works. Let's actually plug some numbers in and see what it spits out. So what if I say I want you to plug 2 into this function? Well, how do I tell you that? Here's how I write it. I say find f, then parentheses 2, like that, close. That's it. That's all I write. And what that means is that you go back up to the function that was defined up there, right? And we said it was f of x equals 4x squared plus 1. And what you do is everywhere you see an x, you replace it with a 2. See? All the x's up there get replaced with 2's. So it becomes 4, then what? 2 squared plus 1. Now, I should probably not write it like that, because that, you might think that's 42 maybe. So what should I do? Parentheses around that 2. Now that becomes critically important if I plug a negative number in, as you'll see on the next example I do. Now, order of operations would tell me to do what first here? Do the parentheses and then that exponent. So 2 squared is what? 4. So I had a 4 in front. Now I have another 4, and then I have plus 1. And then multiply 4 and 4 together. 16 plus 1 is 17. And we are done. So if you look at this machine-wise, you don't have to draw this, but just so you see it. Here was 2. 2 went into this function, right, f. It came out as a 17, didn't it? That's what happened. 2 went in, 17 came out. Now, if I didn't give you the function, okay, let's say you didn't know that up there, and all I gave you was that, hey, I have a function that turns 2 into 17. It would be very difficult for you to guess that it came from 4x squared plus 1. That'd be a big challenge, wouldn't it? Because there could be a lot of functions that would do that. So just having one set of numbers, knowing where it started and ended, isn't really enough for us to be able to know anything about the function. Let's try another one. Yes. Yes, if anyone's going to ask you to evaluate a function, which is what I'm doing right now, evaluating a function, they must give you the function. If not, you don't know what to plug it into. Yep. So find f of 0. So again, replace all your x's with zeros, right? All right, so 4, I'm going to do parentheses again, 0 squared plus 1. Isn't that just 0? So 4 times 0 is 0. 0 plus 1 is 1. So when we plug in 0, we get 1. Agreed? Okay. Now, we haven't talked about this yet, but let's talk about it now. We said earlier that if you put 1 car in, you get 1 car out, right? Not 1 car in, 2 cars out, or 1 car in, 3 cars out, or 1 car in, no car out. That's probably happened before at some point, right? You put a car in a car wash, doesn't come out the other side. It disappears. With both of these, does it appear that for every number we plug in, like we plug into, only 1 number came out? Like 2 went in, 17 came out, right? 1 in, 1 out. 1 in, 1 out. So far it seems okay, right? Let's try this one. Find f of negative 2. You must be careful with parentheses here. You'll have 4 in parentheses negative 2 squared plus 1. See if you can figure that out. Sign-in sheets coming around. What did y'all get? 17. Okay. Here you go. 17. Well, is that okay? Look, when we plugged in 2 up here, we got 17, didn't we? We plugged in -2, we also got 17. That's okay, all right? Because again, all a function needs to be a function is one input, one output. One number in, one number out. I don't care if this number comes out several times. What I care about is if when I plug a number in, it tries to spit out more than one number. Okay? I'll have to give you an example of a function that does that, or see, it won't be a function, but I'll give you an example where it tries to spit out two things, and so it's not a function. Okay? Y'all all right with this? Let's try something a little more complicated. We're going to keep the same function. It's okay if it comes out negative. It won't ever come out negative here with this function, only because it's impossible because we're squaring it, and once we square it, it'll be positive, and then we add 1. So, but let's try this. Yeah, in general, you can have negative numbers come out. That's okay. Your favorite thing to do in the world, how about -3/4? We can plug a fraction in, right? No? Should we just avoid those completely, or what? So I take my 4 in parentheses, -3/4 squared plus 1. Now that means you need to square -3/4, right? And do not break out your calculator. On the side, -3/4 times -3/4 is this, right? So just multiply straight across. -3 times -3 is +9, and 4 times 4, 16. So you get 9/16. So what we get here is equal to 4, and then times, we just said we had 9/16 here, and then we still have the +1, don't we? Now we have to do 4 times 9/16, which is the same as 4/1 times 9/16. Now you could multiply 4 times 9 and then reduce the fraction, or you could see that cross here, 4 goes into 16 and 4. So either way, we should be able to get this fraction reduced out. I'm going to do it by canceling. 4 goes into 4 once, 4 goes into 16 4 times. So that becomes what? That fraction is 9/4? 9/4. So I get 9/4 plus 1. Now I have to add these two together, and the only way to add two things together is to get a common denominator. So how do we change our 1 so that we have a common denominator? 4/4. We can change the 1 to a 4/4. So because I'm trying to add 9/4 to 1, I need to get a denominator below the 1 that matches this one, so I get a 4 down here. But the only way to get a 4 here is to put a 4 on top and bottom. So 4/4 is still 1, but now I have the same denominator. Now add those. 13/4. Remember, when you add fractions, you do not add the bottoms, you just add the tops. So 13/4. Question over there? No? Sign in? Yes. Okay, you're talking about this part right here? Okay, so when we add two fractions, you have to have the same, first you have to have two fractions, right? So I'm looking at that 1, I'm going to erase it. I'm looking at that 1 as really being a 1/1, okay? And then what I'm doing is I'm saying I need denominators here to be the same. So I look at LCD would be like 4 here. So I need to make this a 4 on top and bottom, right? Multiply top and bottom by 4, and they would become a 4/4. Now, since they have the same denominator, we add straight across. 9 plus 4 is 13, and then you keep the denominator the same. Does that answer your question? Okay. Yes. Thank you. Okay, so what happened here is we plugged in negative 3/4, right? We plugged in negative 3/4, and it spit out 13/4. So again, the function just, took a number in, spit a number out. You all right with that? We're going to stay with the same function. I'm going to see how you handle this one now. Find f of m. F of m. So the first thing you should be thinking is, wait a minute, you lied to me. You told me I'm going to plug in a number, it's going to spit out a number, right? Yeah, I plugged in a letter, right? It should, right? Now that's the thing. This letter is actually a number, but we don't know what it is. You see? The question is, if you plug in something like m and we don't know what it is, what happens to m? It replaces the x, right? So just rewrite the problem, replacing the x with m and then squaring it, right? And then adding 1. Isn't that what happens? And you can't figure out what that is. Like, I don't know what m is, so I can't square it. So that's it. I'm done. I know that seems kind of like useless, but trust me, it's useful later. Okay. Any questions? I'm gonna start off a new problem with a new function. Okay, here's your new example. And to really stress to you the fact that, like Miguel asked, like, are we always going to be given a function? I said, if you're going to be asked to evaluate a function, you have to be given a function. To stress to you right now that I'm giving you a new function, I'm saying let f of x be equal to, so I'm kind of saying, hey, look, I'm letting our function change here to something new. Our function is now negative x squared minus 3x plus 7. Now, as you'll learn later, this is actually called a quadratic function. And in a college algebra class, you'd be asked to sketch the graph of this, which we haven't really even talked about yet. But that's what you would be doing in college algebra. So this is your first real exposure to a quadratic function. Well, the other one was quadratic too, but I threw some things into this function to try and trip you up so that you can see some of the complications we have. All these negative signs and where I put them and whether or not I use parentheses or not are all going to factor into whether or not you can evaluate this properly. So let's try and find, first of all, f of 3. See if you can figure out what f of 3 is on your own, and then I'll work through it. Okay, what do you think? Anybody feel brave today? 25, any others? 7. Okay, let me try this. That negative in front of the x squared, is the negative being squared? No, it would have to be in parentheses. So that negative is really like a what? Like a -1. So I'm going to stress that by putting a -1 out front. Times, now, what's being squared? The 3. So I'm going to put in parentheses 3 and then squared. And now I have minus 3, and then that 3x means 3 times x, doesn't it? So you can either put a dot in a 3 next to it, or you can put a parentheses in a 3. This means these two are being multiplied, right? Just like 3x means 3 times x. And then plus 7. Okay, order of operations. Do the exponents first. 3 squared is 9. And I'll work my way across. What is the 3 times 3 there? It's 9, but there's a negative in front, right? So it's really a -9 or -9. And then I have plus 7. Now what operation happens next? Multiplication, right? Right here. -1 times 9, -9. -9 plus 7. What's -9? We go across left to right here because all we have is addition and subtraction. So left to right, -9 minus 9 is -18 plus 7, -11. Do you see what I mean? I mean, there's plenty of room for error in there, isn't there? And that was just plugging 3 in. Imagine if you had to plug in like -5. Well, let's do it. Let's try it. I mean, what would happen if we were asked to find plugging in a negative into this thing? Well, that negative's in front still like a -1, right? Times, see if you can do it. I'll give you that much to start you out. The answer's up here. The things to notice about this, first of all, that -1 I pulled out in the front, absolutely have to have that. If you miss that, it's over. I mean, you'll be off. So that -1 that was in front of the x is out here in front. And then since I'm plugging in -5, I make sure I put it in parentheses, I square it. Next to the 3, it was just, remember it was -3x? I put it in parentheses also. That's important because if you don't put that in parentheses, you might think that that means -3 take away 5 instead of -3 times -5, and then plus 7. So after I did that step, I squared -5. Negative times negative is positive. I still have the -1 out front. I multiplied -3 and -5 together to get positive 15, and then 7. Then I put these two together, -1 and 25. That gave me -25. And then -25 plus 15 plus 7 is -3. Yeah, it's -10 plus 7, so -3. And we could plug in a fraction also, couldn't we? Or we could not. Right. What do y'all think about that? Horrible? Okay. You're being honest. I can appreciate honesty. Okay, let's look at another function, okay? One more thing on top, sorry. What's the name of this function? H, right? That's the H function. Now, what is the variable that we use, that I'm using in this H function? I'm using a t, right? Instead of x. We call that the independent variable, but we also call it the dummy variable, meaning that it can be any letter we want, really. I mean, you could use x's, t's, y's, z's, it doesn't matter. We normally use x. That's just kind of the standard letter. But t is going to be what we plug in instead of the x. I also wanted to point out, did I ever talk to y'all about curling the bottom of your t's? Did I talk to y'all about that in here? No? Did we talk about striking your z's? Okay, well, curling your t's is another one of those things. If your pluses look like t's, you might want to consider curling your t a little bit at the bottom so you don't mistake it with the plus sign. Okay, so there's the function, right? Let it be so. Now let's find f of, or not f, sorry, h of 2. So that means everywhere I see a t, I'm going to replace it with 2, right? Anybody getting 1/2? Yeah? 1/2? That's correct. If you got that, I would like for you now to also find h of 1. What do you got? What do you get on top? You should get 0 on top because it should turn out to be 1 minus 2 plus 1. On the bottom it's 1. So the top should be 0 divided by 1. What's 0 divided by 1? 0. 0 divided by any number other than 0 is 1. I mean, sorry, is 0. Yes. It's the other way around, where it's undefined. If it was not, it was 0 on the bottom, that would be undefined, as I'm about to do. So let's take a look at h of 0. See, it's 0 squared minus 2 times 0 plus 1 over 0. Now the top is not 0. If you plug 0 into this function, the top is 1. but the bottom is 0. Undefined. The answer is undefined. You understand why? We cannot divide by 0. All right? It's an operation that's not allowed in our number system. Well, this is the first time we've seen this. Every function I've given you up to this point, we plugged in a number, it spit out a number. Plugged in a number, it spit out a number. This one is saying when you try and plug 0 in, the function breaks down. The function falls apart. So this is like the 18-wheeler trying to go through the car wash. It can't handle that number. Therefore, if you talk about the domain of this function, what we're saying is that there is a number you cannot plug in. Right now for this function, what number can you not plug in? 0. And you'll investigate that more as you go on in your math career and into these higher math classes. You'll be saying, what is the domain? What can you plug in? What can't you plug in? So you'll look more at it. We're not going to focus too much on it. This function up here, I said the previous one, I said it was a quadratic, and you'll study those in college algebra. This is called a rational function, and you actually will study those pretty heavily in college algebra if you take college algebra, and you'll graph them and do a bunch of work with them. So this is your first exposure to that. But you have to be able to plug things into these before you can start to investigate further what they represent. All right. Let me see if there's anything else in here that I thought was interesting. Have you ever seen this function? Or something like it. F of x equals you see those two bars? You all seen those before? It's absolute value. The absolute value is actually kind of like a function. It's like a car wash. The absolute value, what it does is it always spits back the positive of what's in it. So whatever's inside that absolute value, you figure it out, and then no matter if it's positive or negative, you just make it positive. So let's try something here. Let's find f of -3. So we'll do absolute value 2 times -3 minus 1, close it, plus -3 minus 5. So I've replaced all my x's with -3s. What do you get inside that absolute value? -6, then -1, right? So you get -7 in there. And then over on the right side, over there on the other, with the -3 and the -5, that becomes a -8, doesn't it? -3 take away 5 is -8. Now, we want to get rid of those bars. So what is the absolute value of 7, or -7? +7. So this is just going to turn into 7, no more bars, -8. What's 7 minus 8? -1 or -1. So when you plug -3 into this function, it spits out -1. Questions? Yes. As long as if it's negative, it'll just turn to positive. Yep. Same. No matter what's in there, it changes it to positive. Now, the absolute value of 0 is 0. Yeah. Okay, so here's what I'd like for you to do for homework. Look at page 242. Look at problems 37 through 51, odd. Ignore ordered pairs. Now, here's what I mean by that. In the instructions, it says evaluate the functions at the given value of the independent variable. So it gives you a function and starts asking you to find like f of this or f of this, you know, just like I did here in class. But then it says state the answer as ordered pairs. I haven't talked about that, so I just want you to do what I did in class, and when you get to the end, you just box that answer, and that's it. I'll talk about ordered pairs later, all right? I just want to make sure you can plug in. So all of these, I mean, some of them you're going to plug in fractions. There's some that even ask you to plug in decimals. So let's see how you do with this. And we have about, I don't know, 7 minutes. I'll stop the recording. If there's anything that in the last 7 minutes you want to talk about on the exam, I'll be happy to entertain that. If not, you're free to go as long as you signed in. And can someone hit the lights on the way out, please? Yes, uh-huh. Oh, yeah, I see. Okay. This right here? Yeah, you see that plus sign? Yes, you could have just written that -3 minus 5. Because when you add a negative, it's the same as subtraction. Okay, if we have minus a negative, let's say that changes to a plus. But if you have plus a negative, that is subtraction. So that just changes to -3. I just put the plus there because the plus was in the original. Okay?